After soapy detergent, we mention the second type of detergent, which is soapless detergent. Now, a couple of times I mentioned non-soapy detergent just to give a direct contrast to the soapy detergent, that the soapy detergent forms soap, the non-soapy doesn't form soap. However, it should be soapless detergent. That's what you'll write in your exam. Soapless, soapy and soapless. So we look at the second type of detergent, the soapless detergent. The soapless detergent, now we saw in the soapy detergent, the group was O negative and A positive. If you see this, you identify as a soapy detergent. How do you identify a soapless detergent? It has a sulfonate group. It has a sulfonate group. This group here is called sulfonate group. The sodium doesn't change. The sodium ions don't change, but the carboxyl group and the sulfonate group is what change. Okay. Now, soapless detergent are manufactured from petroleum products such as crude oil. You get when you carry out fractional distillation of crude oil, you get hydrocarbons. Now you use an unsaturated hydrocarbon reacted with concentrated H2SO4, and the reaction occurs in two steps. Or you can just say H2SO4, no need of concentration, just H2SO4. So the reaction occurs in two steps. OSO3 first of all is the sulfonate group. This is a sulfate group, SO4 2 negative. However, when you take one oxygen and bring it to the left side, becomes OSO. Now one oxygen has been removed here, so OSO3, and the charge is negative. So this is a sulfate group, this is a sulfate group, SO4 2 negative, and this is a sulfonate group. Okay. Now the reaction occurs in two steps. We took an unsaturated hydrocarbon called dodecyl benzene. This is a benzene group. This is a benzene group, benzene group, benzene group, and benzene group. So this is a benzene group. And what does dodecyl mean? Decyl means decane means 10. And what does do mean? 2. So this is 10 plus 2. That means there are 12 carbon atoms, which is here 12 carbon atoms. So the dodecyl benzene reacts with H2SO4 sulfuric 6 acid to form what? To form dodecyl benzene hydrogen sulfate. Everything, nothing changes. C12H35, C12H35, benzene group bonded, but you add the hydrogen sulfate, which is OSO3 negative, H positive. After which you added this is sulfonation. You are adding the sulfonate group. This is a sulfonate group. You are adding the sulfonate group. So first step, sulfonation. Second step, mean neutralization. C12H35. Now you use this product as a reactant in the second equation. The product of first equation comes as a reactant in second equation. So same product, same compound is now reacting with sodium hydroxide and alkali. How do we know it's a neutralization reaction? There is a hydrogen here and there is a OH here. Obviously, the hydrogen will combine with the OH to form water. Whatever is left is sodium. The sodium replaces the hydrogen. So the product of this, the second equation is it's the same reactant, only that the hydrogen is the same compound, only that the hydrogen is replaced by sodium. So C12H35, benzene group, OSO3, sulfonate group, but sodium ions are replaced. Sodium ions replace hydrogen. So that is the neutralization reaction. Okay. Now, what are the advantages of soapy detergent over soapless and vice versa? Let's look at the soapless advantages first. First of all, we say it comes from petroleum products, and we say soapy detergent comes from, you start reacting fat and oil with sodium hydroxide or potassium hydroxide. So fat and oil comes from plants and animals. However, petroleum products do not. So soapy detergent, the soapless detergent advantage is it does not come from plants. It is a petroleum product. Hence, it saves plants and animals. Another advantage is it is more soluble, and so it is highly efficient. It is more soluble in water, so it's a more efficient detergent cleansing compound, and it does not form scum in hard water. As we'll see how hard water forms scum with a soapy detergent known as calcium stearate, but you will see that later. So a soapless detergent does not form scum in hard water. It lathers easily in hard water. The calcium and magnesium ions in hard water do not affect it. However, the disadvantages are, since it is from petroleum, it is more expensive. As we know, petroleum right now is 165 a liter. So it's expensive, and it is also more non-biodegradable. It cannot be decomposed by microorganisms. As a result, it causes water pollution. Now let's look at the last part, which is how the detergents carry out their functions. So the last part in detergents that we are going to cover is the mode of action of a detergent. Now a detergent has two parts, a hydrophilic head and a hydrophobic tail. Hydrophilic meaning polar, soluble in water. Hydrophobic meaning non-polar, insoluble in water. So when you are washing something, a grease or a stain or dirt, the hydrophilic head will dissolve in the water that you are using with the detergent. Yes? And the hydrophobic tail dissolves in the dirt. And the hydrophobic tail now breaks down the dirt into smaller droplets in a process known as emulsification. Now, between these two detergents that we have drawn here, the first one and the second one, I'd like you to identify which one is a soapy and which one is soapless. So seeing the sulfonate group here, what did this tell you? That this is a soapless detergent. Soapless had a sulfonate group. And COO negative Na positive is soapy detergent. Now let's see which part of this is has the hydrophilic head and the hydrophobic tail. The hydrophilic head is the functional group, that is the sulfonate group together with the sodium. And the hydrophobic tail is the R group. Okay? Now in the soapy detergent, the hydrophilic head is, we divide it here, is the functional group, the carboxyl group and the sodium group. And the hydrophobic tail is the long chain organic compound, which is C17H35. Now we go to the formation of scum. As we said, hard water, soapy detergents form scum in hard water. One of the disadvantages of soapy detergent is it forms scum with hard water. Now how is scum formed? First of all, what is the effect of scum? It does not lather easily, so soapy detergent does not lather easily. So it wastes soap and it dirtifies cloth. Okay? Now, how is scum formed? What is the formula for scum? In hard water, we have calcium ions and magnesium ions present. Calcium ions, magnesium ions. Now, when you have sodium stearate or sodium octadecanoate, this is sodium stearate, or you can say sodium octadecanoate. Same thing. When the fatty acid reacts with sodium hydroxide to form the soap, is sodium stearate or octadecanoate. So when sodium stearate, this compound, is reacts with the calcium ions in the hard water, the calcium ions are replacing the sodium ions. So instead of sodium stearate, we will have calcium stearate. What's the formula for calcium stearate? It is C17H35COO into brackets 2 and calcium. Why is the 2 here? Because calcium is valency 2. And the sodium ions that were replaced come in aqueous form. So this is a solid form and it is insoluble. That's why it dirtifies cloth and it wastes a lot of soap, because soapy detergent does not lather easily with hard water. Okay, that's it about scum. Now, what is the polluting effects of detergents? One is that they are non-biodegradable. They cannot be broken down by microorganisms. Hence, they cause pollution of the environment. And secondly, they cause eutrophication. When disposed into water bodies, they cause growth of surface plants, which is eutrophication, which has its own effects. So these are the two main polluting effects of detergents that you can know. Thank you for watching. I hope you enjoyed the lesson. If any other subtopic or topic that you feel you want me to explain, kindly drop your suggestions in the comment box and I will oblige to. Thank you so much. Stay tuned. If you like my channel, subscribe.